Okay, we're now recording. So, welcome everybody. This is actually first grade. All right, for everybody, we are done with module 16, and so we're gonna take some time today. As you can see, we're gonna review module 16 right here. I've got we're gonna do at least 4 problems, maybe 5. We'll see how much time we've got from each section and each type. As a reminder, when you submit homework, you need to make sure you label your assignment. Put your name on it, put the assignment, page number, the problems that you do. Okay, because I just need it's easier to see it. And sometimes when I'm going through it quickly, I don't remember what the page numbers are, and when I see it on your page, then I can go through and see. You know what I mean? It's just some efficiency stuff. We are going to finish 16 tomorrow with the quiz. We've got one more person to take the quiz from the last quiz, and so if that happens, it's supposed to happen today. If that happens, then we'll go over that on Friday, that quiz, and probably kick off our next section. And we're down to about 4 weeks, and so we really only have we have to do the solids, which are cones and spheres and prisms and all that good stuff. I'm not sure how much more we're going to get. We might, if we get done with that, we might come back to a couple other sections, but we're definitely going to do those solids. We're going to do another unit test, so good or bad, we're going to do another unit test, which is 100 points, and that's going to be over circles. Okay? Any questions about the plan, kind of, sort of, as we continue on? All right, so get out. You don't need your book open. You just need some paper, notes, that kind of stuff. This is the prep for the quiz. We do have one problem. Don't put your book too far away. We are going to get to it eventually. We do have one problem from the book, but we're going to do this first today. All right, so let's take a look. We'll focus in. Here's the first problem we want to do. Circumference is 90 centimeters. What is the radius? The nearest tenth. I'm going to give you about 2 minutes to do. That's how we're going to do it today. And then I'm going to actually do the problem for you. Let me get my wonderful timer going. You guys want some Jeopardy music in the background just to liven you up a little bit? Let me see what I can find. I didn't say ABBA music. I said Jeopardy music. There's the problem. You got to find the radius. So use the circumference formula. You're not finding the length of an arc. This is just real simple. Use the circumference formula. I'm not going to want to listen to Jeopardy music all day, so I'm going to need some variety. Okay, so let's take a look. Pause the background music. All right, so if the circumference is 90, I'm going to use a different piece of paper here. Okay? So number one, if the circumference is 90, did I say centimeters squared? Okay, so then the formula is 2 pi r, or pi times diameter. Now make sure you have those memorized, because I will, for the quiz, those won't be up there. I'll have those erased. Okay, so you need to know the circumference formula, and you'll need to know the area formula. Okay, all right, and so then we asked for what the radius was, so let's use this one since that's the one we asked for. Okay, and so since we know 90 is equal to C, I'm just going to substitute 90 in for C, and I end up with 90 is equal to 2 pi r. Okay, and so what is my variable, my unknown, what I'm looking for? I put a little box around it, and so now I'm going to divide by 2 pi. Okay, and so now I have the radius is equal to 90. I just switched sides of the equal sign, does not matter. I'm going to put that into the calculator and see what I end up with. Okay. The glare can get us in that. All right, here we go. So 90 divided by, we'll go 2 pi. Notice how I put that into the calculator with parentheses next to each other. 14.3. And so the radius in this case is 14.3. Did I say round it to the nearest tenth? There we go. 14.3 centimeters. Okay. Questions? Anything you want me to explain on that? Now, tomorrow on the quiz, it could say find the diameter. If we know what the radius is, don't multiply it by 2. Right? If you go that route, or you could just use the pi times diameter. It could be find the circumference. Like they give us the radius and the diameter. All you gotta do is multiply it by pi to get the circumference. Okay? So you need to know the formula. 2 pi r or pi times diameter. Are those the only two you need to know? I'll say no, because you need to know how to find the length of an arc. You need to know how to find the area of a sector. All 4 things are up there, but they won't be there tomorrow. Okay? So the length of an arc and the area of a sector. Okay, let's go to the next problem. Here's a sample of what we might see tomorrow. We want to find the arc length. Now the arc measures 150 degrees with a radius of 8. Give your answer in terms of pi. Okay. 2 minutes. Ready, go. We'll do Jeopardy music one more time at least. I'll come back to it. Don't freak out. Ashby. Virtual students, those freshmen that are on the DC trip. You can see I have my morning coffee as always. You just don't have to smell my awful breath. You got it virtually. That's one advantage of being online. Man, Mr. Bennett talked to me this morning and it was awful. His breath was terrible. I think I'm going to buy him a breath mints as a going away gift. Maybe he'll get the hint. Okay, let's see how we did. Stop. Okay, so now find arc length when the arc, you know what I'm going to do? I'm going to make a picture. Okay, so let's do that first. So if you think I can do this. So I want arc length when the arc measures, how much was it? 150. Okay, so there, the arc measure of 150 between those 2 points. Okay. Let's use pink. It might show it better with this background. So there's the arc. Okay. And all right, what else we got here? We know that the radius is 8. Okay, so that's 8, and that's 8. So what are we trying to find? The length of the arc? Okay, so if we're trying to find the arc length, a question mark there, there is a formula that we have went over now for 3 days. It looks like this. S, which is the arc length, is equal to m over 360 times 2 pi times radius. So that is right here on the chalkboard. I have numbers in it. It's 40 over 360 times 2 pi times 4. It's the exact same formula for arc length. That's the area. Okay. And okay, so then let's plug in the important parts of this. The m is given to us as 150 over 360 times 2 pi, and the radius is given to us as 8. Okay, so now I like to do this just so that we can keep things straight. We got 150 right there and 150 right there. That's where it came from. And then we've got 8 right here and 8 right there. We took the radius and we plugged it in. We took the arc measure to put it in, and that's what we're going to now simplify. We don't need to multiply because we don't want to round it. This says leave it in terms of pi. Okay? So we want to simplify the numbers so that we are, I don't know, in reduced form, simplest form, however you want to word that. All right, so 2 times 8 is 16. So we have 150 over 360. Am I still on the screen? Yes. Times 16 pi. Now, there's a couple different ways to do this. Some of you might prefer just to multiply across and then reduce. I personally like to reduce first and then multiply. And that's literally just a preference is all it is. So when I reduce first, I'm going to divide by 10. So now I have 15 over 36. Everyone see that? And then I want 150 divided by 10 is 15. 360 divided by 10 is 36. Now I have 15 and 16 and 36 reduced with a common factor. Let's do 15 and 36. They're both divisible by 3. Okay? When I divide that by 3, I get 5. When I divide this by 3, I get 12. Everyone okay so far? Just reducing a fraction. Now, how about the 16 and the 12? Well, a good way to look at it is that 16 pi is over 1. So this is in the numerator, this is in the denominator, and we're multiplying. They're not equal to each other. We don't cross multiply. And so we just reduce. The 16 and 12 are both divisible by 4. So we'll go 4 here. 16 divided by 4 is 4. And 12 divided by 4 is 3. Got it? Now I'm going to multiply straight across. 5 times 4 times pi is 20 pi. 3 times 1 is 3. Move it on the screen so we got it. And this is going to be in radians because it's arc length. Questions with the reduction of fractions? Is that what we struggle with? We don't know how to reduce fractions?
I entered in my calculator the first part, 150 over 360 times 2 pi times 8. I got the same answer as 150 over 360 times 16 pi.
Okay, this reduces. Yeah. You should ultimately, though, reduce it all the way down to here. Got it, Cindy? We good? Nathan? Okay. All right, let's go to the third one. Now, this one we're using the area of a sector. Area of a sector. Area of the sector is 32. We're solving for x.
Is that 4?
Yes, we're using that formula over there. Find the area of the sector. Are we going to need another 2 minutes? I can extend the time.
No.
It don't matter. I don't get it. "10 hours of Jeopardy music." Who would do that? Jeez. Glad I did, though. Okay, so let's see. How in the world do we do this? We want to solve for x. Let me recreate the problem. So we've got a circle. Ooh, that's not a very good one. I've done much better, but oh well. We got a circle with x. We want to find the sector. Well, we don't want to find the x. We solve for x, but we know that the area of the sector has a value. Area is 32 centimeters squared. And the radius is 4. And okay. So what we don't know is what we need to find is this value right here, which is x. Because if that's a central angle, which it is, then we know that from here to here is x. And so our formula for the area of a sector is m over 360 times pi r squared. That's over there on the chalkboard. So we've talked about quite a bit. So let's plug in what we know. we know that the area is 32. So I'm going to put 32 over here. M is what we don't know. So we're going to go 360 there. And we're going to go pi times 4 squared. Let me pause. So all I've done is substituted the area right there in the radius. That's all I've done. Now, I've got to use algebra. I have to solve for m. Got to solve for m. Okay? That's my unknown. I put a box around it. So, for me, I would simplify the squared first, the 4 squared, and get 16. Let's do that. Take it really slow on this one. So we got m over 360 times pi times 16. Okay? Now, my unknown is still right here. So I have to undo whatever they're doing to my variable. Now, since I'm multiplying and dividing, it doesn't matter the order. You know, PEMDAS, remember that? It doesn't matter the order, okay? Because it's all multiplication and division. What that means is I could divide by 16, divide by pi, and multiply by 360. Does not matter my order. I could multiply by 360 first and then divide. It does not matter the order. Okay, I can't emphasize that enough. But there's 3 things I'm going to have to get rid of. I'm going to have to take to the other side. I'm going to have to take this pi to the other side. I'm going to have to take the 16 to the other side. I'm going to take this 360 to the other side. Because when I undo, the reason I'm undoing whatever they're doing is because I want to isolate my variable. I got to get my variable all alone. Got it? Okay, so here we go. First thing I'm going to do is divide by 16 and divide by pi. Okay, so I'm going to go like this. I'm going to divide by 16. Whatever I do to one side, 16 pi, whatever I do to one side, I have to do to the other. Okay, so I'm going to go 16 pi over here. Everyone okay with that? We good? Okay, so now let me create some space. I'm gonna go up here. So 16 and the pi reduce on this side. And so over here, the 32 and the 16 is going to reduce to 2 and 1. So I have 2 over pi is equal to m over 360. That's all I have left. Let me pause, make sure everyone is with me. My unknown is still this. Remember, pi is not a variable. Pi is a number. So now to undo m over 360, I'm going to multiply by 360. Whatever I do to one side, I have to do to the other. Kind of out of room over here. Make that kind of small. Multiplying by 360. So the 360 and the 360 cancel. And so here I have m. On this side, I have 360 times 2, which is 720, divided by pi. Okay. Let's put that into the calculator. Did it say that we had to round it? Was there any wording on rounding? Yeah, round to the nearest tenth. Round to the nearest tenth. Okay, so here we go. Clear. 720 divided by pi equals, round to the nearest tenth, 229.2. Are we finding area? We're not. We used area to find the length. Remember, this is a degree measure, right? 229.2 degrees, and that is what x is equal to. Okay. Now, my picture is not very good because that doesn't look like 229 degrees, does it? But that's just how the math works. Don't let the picture dictate in a case like that. All right. Questions? We good? All right. Let's do one more problem. Now you got to open up your book. This is one where I said you need your book. All right. So turn to page 879, number 22. 879, number 22.
Definitely did not get copies.
879, number 22. Okay, let me read it aloud for us all so we're looking at the same picture and we understand the problem. Greek mathematicians. That's not me. I'm Serbian, Yugoslavia. Yeah. Grandma. Straight from, well, Yugoslavia is not even a country anymore. It's Bosnia now. Anyways, they moved to Pittsburgh. I had great stories someday, I'll tell you about it. Okay, so Greek mathematicians studied the Salamon, a figure bounded by 4 semicircles. Do you guys see the 4 semicircles? You got one here, one down here, one there, and then the big one. 4 semicircles. And then it says, what is the area of this Salamon? The nearest tenth of a square inch. So we are finding the area of everything in here. It's kind of a neat little design, isn't it? Okay, so, well, let's think through this. All right, so if we look at it like this, we have a half of a circle. Does everyone see half the circle? Like if I would draw this all the way across, that would be a semicircle or a half of a circle. Do you see that? But there's gaps, right? I mean, there's 2 half circles that we would subtract away, but then there's a half circle that we would add to. Does that make sense? Yeah. So that's a 1 and that's a 1. So I think the radius of the big circle is 2. Isn't that what they have on the problem?
The problem doesn't give a radius.
Oh, yeah. I'm sorry. So its radius is 3. I couldn't tell by the way that the problem was. Yeah. So the radius is 3 inches. Let me go ahead and write that down so we're on the same page. Okay. So, but let me first of all get back to our understanding what we have. So we have a half circle, and then we've got a cut out here, which is a half circle, and we got a cut out here, which is a half circle. So it's like we'd subtract those 2, but then we'd have to add here. So if we have 2 that we would subtract and 1 that we would add, that means total, we just need to subtract a half smaller circle. Wouldn't that give us our total area? Think through it now. The whole half circle and then minus a half of the smaller circle. One of these.
A semicircle is equal to
180 degrees. Hold on though, right? Everyone see that? And this is going to give me my area. Okay. All right, so let's first of all take care of the area of the half circle. So that's 180 degrees, as we know, a semicircle. And then that's times pi r squared, and our r is 3. So that's going to be 3 squared. And then the area of the smaller one is just the same thing, 180 degrees, times pi 1 squared, because this is a 1 for the radius. Okay. All right, so now let's simplify. So this is 1/2 And this is 9. 3 squared is 9. Minus 1/2. And that's 1. Let's clean that up a little bit. So we have 9 pi over 2 minus pi over 2. Well, these are like terms. So 9 minus 1 is 8 pi over 2. That's how I deal with fractions. Just subtract across. So I end up with 4 pi. Did they tell us to round it to anything? Yeah, to the nearest square inch. So 4 times pi is our math that we have to operate. 4 times pi. 12.6 then? Oh yeah. 1/10 of a square inch. So there is the area, and since we're finding the area, it's inches squared. That's an interesting problem. I like that. You know, you had to subtract those two and add this one. Subtract these two and add that one. It's a neat little design, and so the area of the whole thing is 12.6 inches squared. Questions? All right. Okay. All right, let's do one more. We got time for one more. Let's do one more for review. All right, so I'm going to make this one up. All right, so let's say we have a circle with a sector of 70 degrees. The arc measure is 70 degrees. And it has a radius of 3. Find the area of the sector. Nope, I made it up.
Oh, okay. Just trying to find it.
You guys got an answer?
Yep.
Okay, let's see. So we know that the area formula is m over 360 times pi r squared. So we go area is equal to 70 over 360. I didn't tell you to round it, did I? Okay, so we'll go pi, we'll leave it in terms of pi then. 3 squared. And so area then is equal to 70 over 360 times 9 pi. Multiply across. 9 times 70 is 630 over 360. All right, let's reduce. 63 over 36. Are both of those divisible by 9? Yeah. And what do we get? 7 over 4. 7 pi over 4 inches squared. All right, we good? All right, tomorrow we'll have a quiz. All right, virtual students, any questions, just send me an email.